In this video, we'll be talking about Newton's 3 laws of motion. Here is the first law of motion. Every object persists in its state of rest or uniform motion in a straight line, unless it is compelled to change that state by forces impressed on it. So basically what this is saying is it's just explaining inertia of how a ball, see a ball here, a ball is at rest, and you'll need an external force in order to make this ball move. It won't move just by itself. Now, by the same principle, if the ball has a constant velocity and there's no other force there's no force in this scenario, even though there's no force acting on this ball, it will continue to keep going at this constant velocity since the acceleration will be 0. And the only reason this ball would stop is if there was an external force that stopped it. So you could say the force of friction would be one force that would potentially stop this state of uniform motion. Newton's second law is probably one of the most used of his laws in just when you're doing the actual computation in physics, and it's just F equals mass times acceleration. And this explains what we looked at in the previous law, which was if we took a ball which was traveling at constant velocity, there would be no force acting upon this ball. And the reason there's no force is because acceleration is 0, and when acceleration is 0, it doesn't matter what the mass is, the force is still the net force is still going to be 0. And yeah. And finally, Newton's third law of motion is that for every action there is an equal and opposite reaction. And so this basically is just explaining the nature of how forces work. And one application of this law is, say there was a block on, let's say, the ground. There's the force of Earth on the blocks, which is basically gravity, which is going to push down on the block, which is what attracts it to the Earth. But at the same time, there is an equal normal force that's in the opposite direction, which is basically the Earth pushing up on the block. And basically, this is why okay, so if you go back to the second law, we say sigma F is equal to mass times acceleration. And so since these two cancel out, there is no acceleration. Otherwise, if you just had this one force, technically, that would mean that the block is moving downwards, which is not true. And other applications of this law are in aerodynamics. For example, if you're looking at a plane, the thrust that pushes the plane in one direction, so say you have a plane, let's try to draw a plane. Okay, yeah, that's a plane. So what provides the thrust is jet engines, but the jet engines are exerting a force this way, and the reason the plane moves is because of Newton's third law, that for every action there is an equal and opposite reaction.